Good morning, all the participants. You are welcome in our session on innovations in autonomous vehicles. I am Dr. Kulwant Singh, Assistant Professor, Department of Mechanical Engineering, Chandigarh University, Mohali. So in this session, we will discuss about the few innovations in the autonomous vehicles. So in the content, we will discuss about introduction, the history of the autonomous vehicles, autonomy levels, vehicle hardware, top companies, and the innovations on the autonomous vehicles. So let's start from the introduction. So in the introduction, the word that is the autonomous is derived from a Greek word that is autos nomos. So it means self-governed. So it is a vehicle that can drive itself from a place to the another without any assistance of a driver. In other words, we can say that it is operated by an autopilot system. And in the history, the concept of self-driving car begins in the 1920s with the phantom autos, which were operated by a remote controlled unit. And then in 1930, GM sponsored, GM that is General Motor, sponsored a Vision Future Rama by radio controlled car through the electromagnetic field. And further in 1987, Mercedes Prometheus project had a huge success in construction of the vision guided system. And in the 20th century, in 2009, Google jumped with their Google XLab self-driving project, and in 2016 it was spun off to the known as the Waymo. In 2015, Tesla Motors rolled out version 7 of their software in the US that included autopilot capabilities. And Microsoft has performed a partnership with the Volvo as well as with the Toyota to create the autonomous car. Uber and Apple are also the rising player in the self-driving vehicle market. And now these are the autonomy levels defined by the Society of Automotive Engineers. So there is 6 level from 0 to 5. So first, that is the 0, there is no automation, means the manual drive is there. And driver perform all the driving tasks in a vehicle. Then the next is the first level, driver assistance. So the vehicle handles some function with the driver assistance is required in this level of the autonomy. In this level 2, that is the partially automated. So there is a driver is required and can take control anytime. In the level 3rd, that is conditional autonomous. So driver is required but not required to monitor the environment. Driver must be ready to take control at any time during the driving. And next is the level 4, that is high automation. All driving task under the special conditions, and driver can take control anytime. And last, that is the topmost level, that is the 5th, fully automation. So all driving tasks under these conditions are taken by the system, and there is no driver is needed in this system. So the first 3, level 0, level 1st, and level 2nd, these are the human monitoring driver environment. And level 3rd, 4th, 5th, these are the automated system monitor driving environment. So these are the level of the autonomous vehicles. Now the vehicle hardware. So in the hardware, there is first is the LIDAR. Next one is the radar. These are the few important hardware of the autonomous vehicles. Then the cameras. And then ultrasonic sensors that are used in the autonomous vehicles to control the activities. GPS system and CPU, central processing unit. So these are the essential hardware of a autonomous vehicle. Then the LIDAR sensor. So in the LIDAR, that is the light detection and the ranging. It is a sensor and it is a scanner. LIDAR is a scanner. It is a surveying method that measures the distance to a target by illuminating the target with the laser light and measuring the reflected light with the sensors. Data can be used to make the digital three-dimensional representation of the particular target. And LIDAR is mounted on the roof of the vehicle. Then the next sensor is the radar. So radar is an object detection and the ranging system that use the radio waves to determine the range, speed of the objective. It measures the distance of various objects and allow the system to reduce the speed of a car or the vehicle. It covers all the directions. Then the camera. Camera is installed in the front and back of the vehicle. It detects traffic lights and any moving object in front of the car. It is used to identify road markings and traffic signals, and done by the AI, artificial intelligence softwares. All the functioning of the camera is performed by the AI softwares. Then the ultrasonic sensors. So this sensor used to measure the position of the object very close to vehicles. They are used to detect nearby object or measure the position of other vehicle during the parking. Then the GPS system, global positioning system. So the GPS sensor provide the car with real-time information about the surrounding. The source and the destination is marked on the map, and the car uses GPS to navigate itself without human interruptions. Then the next, CPU, central processing unit. So it is the brain of a car, and all the data obtained is fed to the central computer. After data processing, it gives the command to the vehicle. And this is the functional architecture of a autonomous vehicles. There is 3 stages. First is the data acquisition, then data processing, and then actual actuations. So in data acquisition, sensor, radar, LIDAR, camera, and communications. These are the few functions, or you can say the component of the data acquisition system. Then there is the data processing. The information taken from the data acquisition is processed during the second stage. There is localization, mapping, processing, decision making, and controlling. And then the third stage is actuation, that is the performing the task according to the command from the as the input from the data processing unit. And this is the system architecture. The complete view of the autonomous vehicle. So there is a central computer, sensor, rear and the front bumper. There is a back view. Cruise control is also there. There is surrounding view. So this is the complete architecture system of a autonomous vehicle. Now the top companies, or you can say the player of the autonomous vehicles or the car. First is the Waymo, GM Cruise, Argo AI, Mobile, and Tesla. So these are the topmost companies working on the autonomous vehicle. In the Tesla, so Tesla is using, instead of the LIDAR, it uses the cameras and a forward facing radar to handle most of the driving activities in the autonomous vehicles. And its approach to solving computer vision is much harder and will take longer time to achieve. But it has benefit as compared to the other. The cost effective approach is, you can say, preferred by the Tesla. It has collected the highest real world data, and it uses simulator to teach the AI. Now the innovations, AI to the next level, artificial intelligence to the next level in the autonomous vehicles. As the autonomous vehicles are developed with a wide range of the self-driving capabilities, and many of these capabilities are being made possible by the artificial intelligence technology. However, before taking about the big scale deployment for the smart city transportation, more work is needed to improve the AI algorithms and the mapping features powering the autonomous vehicles. So these innovations in the autonomous vehicle, AI and mapping, might help secure a future in which the autonomous vehicles are deployed city-wide. So the first thing is the deep reinforcement learning, DRL. That is the next level. So this method combined the strategy of the deep learning and the reinforcement learning in an attempt to better automate the training of algorithms. DRL has useful application in lower level automation of the vehicles. And it can also provide the value in the vehicle manufacturing, where it can be applied to transform factory automation and the vehicle maintenance also. The next innovation, that is the path planning. Path planning is the decision-making process that autonomous vehicle use to determine safe, convenient, and economical routes. It required taking into account street configurations, static and the dynamic obstacles, and the changing conditions. These models enable the autonomous system to prepare for multiple scenarios simultaneously. Then based on the evaluated probabilities of the each scenario occurring, the system can define how the vehicle responds. And the next is the SLAM, SLAM. That is the simultaneous localization and mapping. It is a technology used to orient vehicle in the real time to the surroundings. This technology can enable vehicle to operate autonomously in the area where maps are not available or where available maps are incorrect. And next one is the HD maps. The high definition maps are the map that include minute environment details, often down to a centimeter scale. And these maps include the details that live drivers would be able to see and interpret the real time while driving, but which autonomous vehicle need ahead of time. For example, lane markings, curve angles, road boundaries, or pavement gradients. So the level of details provided by the SD map help the vehicles more accurately predict behavior and enable more accurate directions. So these are the benefits of the HD maps. So in the conclusion, we can say that it is not only useful, but also incorporate increased security for the passengers, fresh business possibilities, upgraded traffic situations, learners, and the creation of the customer participation. Design and application difficulties which are needed to be solved in the autonomous vehicle before these practical autonomous vehicle can be completely deployed. AI algorithms are just one part of the components needed to power fully autonomous vehicles. Growth is also driven by the integration of the high quality data in the autonomous vehicles. Deep learning models have greatly contributed to the improvement of the autonomous vehicle artificial intelligence. There are still many challenges these vehicles face and which should be dealt with before true maturity can be achieved in the autonomous vehicle. So this is all about our today's session. So thanks a lot. Have a nice time.